In the last couple of videos, we learned how to calculate the correlation coefficient between the two variables and perform significance tests. I would encourage you to watch those before watching this one. In this video, we will learn how we can use Python to compute the correlation and the associated p-value for significance testing. Let's say we want to find out the relationship between the daily returns for stock of Apple, Microsoft, Walmart, and the daily returns on the S&P 500 index. First, let's import our standard libraries. Now let's download a sample of daily index prices from Yahoo Finance for the 4 tickers for, let's say, past 10 years. Let's call the new dataset prices. Once we execute these lines of code, Python will pull the adjusted closing prices for Apple, Microsoft, Walmart, and S&P 500 index from Yahoo Finance. In general, it is a good idea to view the data to make sure that there are no errors while downloading the data. The head or the tail functions can be used to see the first or the last 5 rows. Now let's calculate the log returns by executing the following line of code. Finally, we can drop the missing observations by using the drop_NA function. We can use scatter plots to visualize the relationship between any two returns. We can do that by using pair plot function from Seaborn library. It seems most of the returns are positively correlated. We can calculate covariance to quantify the relationships using the COV function as follows. This gives us variance-covariance matrix with variances reported on the diagonals and covariances in the off-diagonal locations. While covariance tells us about the positive association between the various returns, it does not tell us which pair of returns has a stronger association. The covariance is also affected by variances of the two random variables. By factoring out the standard deviations, Pearson's product moment correlation or correlation coefficient provides a useful measure for the strength of the association. Correlation coefficient R is calculated as the ratio of the covariance between the two variables and the standard deviations of both of the variables. The correlation coefficient can only take values between -1 and 1, irrespective of the covariance and the variances of the two variables. There are several different ways for calculating the correlation coefficient in Python. We can use Pearson R function from scipy.stats to calculate the correlation coefficient between two variables and the associated p-values. After importing the required library, we can execute the following line of code to get the correlation coefficient and the associated p-value. The output shows us that the returns on a stock of Apple and Microsoft are highly correlated with a correlation coefficient of 0.46. The p-value of less than 0.01 shows that the correlation coefficient is significantly different from 0. We can also use the CORR function of data frame to generate the correlation matrix between all of the returns in our dataset. The output shows us that the diagonal items are 1. This is because the variable with itself must be perfectly correlated. The off-diagonal items show the correlation coefficients between the return pairs. Finally, we can use the heat map function from Seaborn library to graphically show the strength of the correlation between the various variables as follows. The numbers above the diagonal are repeats of the numbers below the diagonal. This is due to the fact that the correlation between returns for, let's say, Apple and Microsoft is the same as the correlation between the returns for Microsoft and Apple. We can use the mask function to hide half of the matrix to present only the relevant information by executing the following lines of code. Covariance and correlation only works for linear relationship between the variables and will provide a biased estimate of strength of relationship for the non-linear association patterns. Finally, remember that the correlation does not imply causation. In the next video, we will learn about simple linear regression model that can be used to find the causal relationship between the two variables.